So here is tomorrow's severe threat. We have this this slight risk, level 2 out of 5 down here in Dixie Alley, Mississippi, Arkansas, parts of Louisiana, towards parts of northeastern Texas, southeastern Oklahoma, and parts of Mississippi as well, toward Meridian, and going all the way into Alabama with a marginal risk, all the way towards San Antonio, Lawton, Oklahoma, Joplin, Missouri, Springfield, Poplar Bluff. We also have a marginal risk up here in the Ohio Valley as well, Indiana and Ohio mostly here. So what's likely driving a severe threat in the southern mode of this tomorrow is a shortwave trough moving through the area. You can see the enhancement at the mid-levels as this shortwave moves through, with the main trough up to the north here. I know this looks kind of wonky, but centered on this southern mode, right? We go back and look at the, well, day 2, excuse me. All right, here we go. So see how the energy is kind of focused in this area. I don't know if it doesn't look that intense, at least not that focused really here, but we'll have to see how this plays out. And that's probably why there's only a slight risk tomorrow. Doesn't seem that impressive, but we'll have to see how this plays out into tomorrow, right? I know I already said that, but not that impressed. Most of the dynamics are further up to the north here. But you can see on the northern mode of this, where we have some energy moving through the flow as well, likely bringing that severe threat up to the north. And as we look at this here, this is the beginning of the period, right? Tomorrow, 2 a.m., 3 a.m., HRRR model. Convection moving through the northern mode of this. Some rotating storms may be getting going by the evening hours in the northern part of this threat area. And let's take this off. Okay, taking that off. Maybe some rotating storms up here to the north, Memphis, Little Rock, Arkansas. Maybe a warm front here. Let's take a look at the dew point values here real quick. We can see where the highest dew points are. Pretty moist atmospheric profile here. So storms can fire in this regime. Definitely plenty of moisture in the atmosphere. All right, going back to the radar. Let's look at that real quick again. On the southern mode, this looks like a lot of just showers here in the southern portion of this area, although storms start firing back here in Oklahoma City by 9 p.m. on the back end of this here. Maybe some supercells getting going here as well, and maybe an MCS type feature moving to the south and east with this, as well as these storms moving to the south and east. See how this pushes into parts of northern Mississippi, and then eventually into Alabama, with maybe some rotating storms on the back side of this. Maybe you have 2 different distinct areas of severe weather. One on the back and southern, like on the area that didn't really get a lot of convection initially. Maybe some storms firing in Dallas area, right? But they moved to the east here, and really this HRR model wants to get these going in the overnight hours. Overnight hours are terrible for severe weather because people are trying to sleep, you know. So let's take a look at the parameter space here real quick. If you notice, the hodograph here shows a pretty straight sheared profile here. So at least with this, right? Not a lot of curvature. And you see the thermodynamic profile here is pretty, there's not much dry air here, preventing convection from firing. Okay. And with a straight hodograph, that tells me that, you know, we're going to have more of a wind threat and a hail threat here than tornadoes, at least at this portion of it. Now we get further back in time with this. Initially, we got a cap in place way up there, right? So that may prevent convection and fire initially. Okay, so we're talking in the afternoon hours, 11 a.m., 12 a.m., 1 p.m. The cap lifts, and that's when you may get convection firing overnight. And then, that's it for that. So to me, this more looks like in this area looks more like a wind threat. Now let's move over here. Let's go back in time a little bit with this. Look at the hodograph and thermodynamic profile. Quite a separation in dew point and temperature here. But so that tells me you see the lapse rate at the low levels, how steep it is. 83 and 58. That tells me likely more of a hail threat with that separation inverted V profile there. Okay. Maybe as we get into the evening hours, the temperatures come down. We could get some more tornadic storms. But this looks more like to me like a hail and wind threat here with these storms. All right. Now, let's go back to the Dallas area where this storm's supposed to fire. More of a straight line wind threat too here. So now let's go back further to the north here. Just one more reading here. Pretty nice thermodynamic profile here, 7363. Not a lot of curvature here, so I don't know. Not that impressive, but like I said, this area looks more like a wind and hail threat tomorrow. So this is timing, right? So you got into the Thursday. This is Friday, 2 a.m., 7 a.m. Convection is already firing here. Maybe some rotating storms pretty early in the morning here. So we'll have to see. This is Eastern, right? We'll have to see if this clears out in enough time for convection to get going on the back side of this. This early on convection may have a big impact on future convection as well, as far as tornadic type storms, because it'll eat up a lot of the thermodynamics, the energy in the atmosphere, right? So 9 a.m., 6 p.m. So if the atmosphere has time to recover into the evening hours before the sun sets, definitely could get some pretty severe storms here with large hail and wind gusts here. So that's my take on tomorrow's threat. I appreciate you watching. Have a great day, and God bless.